Welcome to AI Paper Slop. Today we're jumping right into a paper from Microsoft Research and UW-Madison. It's called TRACE. That's Turn-Level Reward Assignment via Credit Estimation for Long Horizon Agents.
Yeah, and the core problem it solves is sparse feedback.
Right.
When you train multi-turn agents, like web searchers, using reinforcement learning with verifiable rewards, or RLVR, you generally only get this binary final reward, success or fail.
Which doesn't tell the agent which of its, 50 tool calls were actually useful.
Exactly. So Trace fixes this by using a frozen reference model to score how much closer every single individual tool call gets the agent to predicting the gold answer.
And it does this by converting those probabilities into log ratio state values, right?
Yeah, which creates these really dense turn-level temporal difference rewards, or TD rewards, that actually telescope perfectly.
Which gives massive performance gains, like QN3-4B jumps from a 7.2 success rate to 35.6 on BrowseCon Plus. Pure RL, no step-level human labels, no trained critics, and no cold start supervised fine-tuning.
It's honestly a huge leap.
Okay, let's unpack this. Because right now, the community heavily relies on group relative policy optimization, or GRPO, right? Which is outcome only.
Right, yeah.
And it's kind of like grading a student's 50-step calculus proof purely on whether the final box number is right.
That's a really good way to put it.
I mean, if they make a brilliant deduction in step 3, but then make a silly subtraction error in step 49, that whole trajectory gets a negative advantage.
Yeah, and if we connect this to the bigger picture, that outcome-only approach is brutal for agentic trajectories as the horizon grows.
How so?
Well, a failed rollout might start with some really excellent web searches, opening the right pages and everything.
But then it fails at the very end.
Exactly.
Yeah.
So outcome-level training undercredits all that good exploration. And on the flip side, a successful rollout might have totally redundant searches that just accidentally coast to a win.
So GRPO overcredits the noise.
Right. The gradient variance just becomes massive.
So why not just use process reward models or PRMs, or even just drop in a strong LLM judge to grade every step like we do in math reasoning?
The paper actually argues explicitly against that.
Oh, really? Why?
Well, process supervision usually requires expensive step-level human labels, or a super heavy external LLM judge, or you use a trained process reward model, which can suffer from reward hacking.
Oh, right, where it drifts away from final answer correctness.
Yeah, exactly. Trace explicitly avoids all of this overhead.
So how does Trace get these dense rewards for free then?
This is, I think, the cleverest trick in the paper. Instead of training a critic, Trace just uses a frozen copy of the policy initialization.
Like the reference model itself.
Yeah, exactly.
Oh.
But it's not acting as a judge evaluating the semantics, it's just acting as a stable probe.
Okay, so at every tool call boundary, like after an observation comes back from a browser search, this frozen model checks the log probability of the known gold answer.
Right. It basically asks, given this prefix, how predictable is the final answer? And if it gets more predictable, the agent gets credit.
Wait, but the paper explicitly says that just looking at the raw jump in log probability is a bad idea. Why is that? I mean, a jump is a jump, right?
Well, let's look at the math. A raw jump from negative 10.6 to negative 7.1 is numerically a delta of 3.5.
Right, okay.
But a jump from negative 5.1 to negative 1.5 is also a delta of 3.5.
Numerically the same.
Yeah, but that second one is way more valuable because it almost completely closes the remaining uncertainty gap.
Oh, wow. Okay, I see.
This is exactly why Trace uses a log ratio state value. It measures the relative fraction of the initial gap that was closed.
So they use that initial gap, D0, and divide by the current gap, DK.
With a small epsilon offset so the math doesn't explode, yeah.
Here's where it gets really interesting to me, though. It's the elegant telescoping property of this math.
Oh, the telescoping is beautiful.
Right, because it's a log ratio, TD reward, redundant intermediate steps perfectly cancel out.
Exactly. State 1 minus state 0 plus state 2 minus state 1. Yeah. The intermediate state ones just vanish.
So an agent can't inflate its reward by padding the trajectory with useless tool calls.
Right. It gets exactly 0 total credit for stalling.
But the basic math only really works for immediate feedback, right? Real-world tool use usually has delayed effects.
It does. And that introduces the delayed evidence problem.
Like, an example from the paper is a browser search tool call. It might just return a list of blue links. The answer likelihood doesn't actually jump until the next turn when the browser open command actually reads the text.
Right. So how does that initial search get the credit it deserves?
Yeah, how does Trace handle that?
They use a k-step truncated TD backup, basically a look-ahead horizon.
Okay, looking ahead into the trajectory.
Yeah, specifically they found that a k=3 look ahead with a discount factor of 0.8 worked best in their ablations.
So that allows the reward from reading a document to basically propagate backward to the search query that found it in the first place.
Exactly. The temporal discount incentivizes efficiency, but the foundational search still gets positive credit.
And they don't throw away final outcomes, right?
No, not at all. Trace mixes this dense turn-level TD credit with the standard GRPO group relative outcome advantage.
So the final answer correctness is still the ultimate anchor.
Always. It keeps the model grounded.
I really have to emphasize the purity of this training setup too, because they use no cold start supervised fine-tuning.
Yeah.
None. No agentic mid-training, no live web data, just the base model and pure RL.
It's a massive flex on minimal supervision.
Speaking of flexes, let's talk about the mind-blowing scale and the empirical results here, because that's what proves this actually works.
The benchmarks are wild.
Yeah. So they built synthetic multi-document search task over Open Researcher for the training phase, but then they tested it on the closed web BrowseComp Plus and open web benchmarks like GAIA, BrowseComp, and XBench Deep Search.
And the numbers are just fantastic.
I'm reading them right now. Using the Q134B base model, Trace jumps performance from a baseline of 7.2 all the way to 35.6 on BrowseComp Plus.
And on the 30 billion parameter model, it jumps from 8.4 to 42.6.
That is huge.
But what's fascinating here is the open web transfer.
Yeah, tell me about that.
Even though the agent was trained in a completely closed synthetic environment, it generalized beautifully to live open web APIs.
Like GAIA.
Yeah, on GAIA, it hit 52.0 with the 30B model, and it even showed cross-lingual transfer to the Chinese QA benchmark XBench Deep Search.
Hitting 45.0 there, right?
Exactly. It learned the abstract methodology of search so well that it transferred out of the box.
And there's this crucial graph in the paper about the learning dynamics that I loved. It shows Trace scaling up the interaction length way faster in the beginning stages of training compared to GRPO.
Right, because it's getting those local rewards.
So it learns to comfortably execute longer sequences of environment exploration early on. It feels safe exploring.
Because it's not just getting slapped with a binary fail after 10 steps. It gets told, hey, your first 3 steps were actually great.
Exactly. So to really see what the model is doing, let's look inside the trajectories. The paper has these qualitative examples of when agents succeed and fail.
These are my favorite part of the paper.
Me too. Let's start with a success case, the P4 example. The target was Godspeed Tactical. The agent issues a search, and the crucial exclusivity claim is literally sitting right there in the search results snippet.
It hasn't even opened a page yet.
Right. And Trace immediately assigns a massive plus 5.48 credit to that search action itself.
And then the agent gets a little confused and issues some redundant find commands, right?
Yeah, but Trace gives 0 credit to those redundant commands. It surgically identified the exact move that solved the puzzle.
Which is just so cool to see playing out in the data.
But the failure example, N1, is even better. It's honestly hilarious. The agent has the gold answer secured. The answer is leap of faith.
Okay.
But then it issues a literal browser find command for a phrase it completely hallucinated from its own earlier query.
Oh no, what was the phrase?
It searches for, quote, loft drop trust exercise.
Oh, wow.
And when it gets a partial match on its own echoed text in the HTML, it discards the actual gold answer and tanks the whole trajectory.
That is tragic.
But the beautiful thing is, Trace correctly assigns a brutal negative 4.83 penalty to that specific bad find command.
That proves that simply completing a tool call is not progress.
Right. Under outcome-only GRPO, that whole trajectory would be penalized, killing the optimal search behavior it used at the start.
Exactly. Outcome-only GRPO would penalize the whole thing. But Trace surgically identifies exactly which tool call threw away the victory.
So what does this all mean? Is this the silver bullet for all agents?
Well, the authors are pretty upfront about the limitations. Trace really relies on the gold answer being a compact string that a reference model can easily score.
Like in QA or search.
Right. But if you have open-ended tasks, it gets tricky.
Yeah, it does.
Which leaves you with a really provocative thought to ponder.
Yeah.
If Trace works perfectly for compact verifiable answers, how could we adapt this for open-ended software engineering agents?
Oh, that's interesting, because the gold answer there is a massive multi-file code patch.
Exactly. Log probability won't work as a state value proxy for thousands of lines of code. But could we instead use a frozen reference model to score the predictability of passing intermediate unit tests?
Oh, wow. Wait, really? Just checking if a unit test is likely to pass?
Yeah, that's the next frontier for credit assignment in Agentic RL, finding reliable proxies for those complex open-ended tasks.
That is something for everyone listening to mull over. Thank you all for tuning into this deep dive into the source material on AI paper slop.
It's been great.
Remember to check out the trace paper if you're building multi-turn agents. See you next time.